Good morning or good afternoon if you're watching this video. It's either Monday, November, 14th or Tuesday, November 15th. Please write down these notes. I'm going to have you guys take a picture from your Chromebook or your iPad or your phone and upload it for participation points. So we are just going to be reviewing, or maybe if you weren't here last Wednesday or Thursday, this is the first time you might be learning how to find the distance between 2 points. In your notebook, it might be page 19 or 20, doesn't matter which one, just go ahead and write down these notes. And I want you guys to look at my lightsaber here. And when we talk about horizontal change on the X and Y plane, we're talking about a change in the X's, in the X values, the X axis. And when we're talking about vertical change, we're talking about that Y value change. So for horizontal change, we look at the change in the X axis or the X values. And then when we look for vertical change, we're looking at the y-axis, right? So the x-axis, we could say from right to left. So like right to left. And then the y-axis is up or down. Just a heads up, I'm having some issues with my Apple Pencil, this software. I think I need to update it or something. It's either super thin writing or super thick writing. I can't get it between, and I've tried everything. So I'm sorry that the writing is like really chunky. I really can't change it. So anyways, so if we're looking at the distance between this horizontal change, we're going to look at the x values. So from -6 to -2, just find the distance between those two. In other words, the absolute value of -6 minus -2, which would be +4. Now, if all of these units are by ones, then you can count 1, 2, 3, 4. But if it's not by one, sometimes these are by twos or by halves. It's not always the most accurate to count, but in this case, you can count the distance between those 2 points, and it's 4. And it's that's a horizontal change. So that distance is, the distance is equal to 4. And if we look at the vertical distance right next to it, we don't look at the x values. When we're looking at vertical change, we look at the y-axis or the up or down. So we look at the y coordinates, 5 and -2. So to get from 5 to 0, that's 5, right? And then to get from 0 to -2, that's another 2. So that's a distance of 7. So the distance is 7 here. All right, so what happens when you don't have a horizontal change or a vertical change and you have a diagonal change? When you have a diagonal change, as in a line that's slanted, we actually have to use the distance formula, or we can use the Pythagorean theorem by creating a right triangle. That's what we did last week on Wednesday and Thursday. But here we're just reviewing the distance formula. So go ahead and write distance formula. And you can write that a little higher up. Let me see if I can move this. No, I don't think I can move this. It's okay. So the distance formula is D equals the square root of the change in the x's, x2 minus x1 squared, plus the change in the y's, y2 minus y1 squared, all under the square root. So hopefully you watched the videos from last week where I teach you where the heck the distance formula comes from. It comes from the Pythagorean theorem, and it's just a different version of the Pythagorean theorem combined for 2 points to find the distance between those 2 points. So let's just get into an example. Again, you're writing this down. The example question says, find the distance between each pair of points. So find the distance between each pair of points. And I'm only going to give you one example because I don't want to make this video super long. So let's find the distance between -7, 5 and -8, 10. All right, so I'm going to go, I could plot this just to get a visual, but I don't have to plot this. You guys, I do want you to plot this, but I just want you to know you don't have to do this. So -7, 5 is right here. And then -8, 10 is up here. Negative 8, 10 is up here. And we're trying to find this distance right here between them. In other words, the hypotenuse of a right triangle, if we were to draw a right triangle, but that distance is a diagonal distance. So it's hard to do that using the Pythagorean theorem. We can, but I would rather use a distance formula. So let's label our distance formula. So first, this is going to be x1, y1, our first x, our first y. We can also say x sub 2 subscript, y subscript 2. So now that I have them labeled, I'm just going to insert those, I'm going to plug in those values into the distance formula. And I'm going to write d equals the square root. And then my x2 value is negative 8. My x1 value is negative 7 squared plus y2, which is 10, minus 5 squared. So now negative 8 minus negative 7, we can change that into addition of the opposite. So we get negative 1 on the inside. Negative 1 squared plus 10 minus 5 is 5 squared. And I'm going to always try to keep d equals aligned. And so negative 1 squared is 1 plus 5 squared is 25. And now 1 plus 25 is 26. And the square root of 26, I can input that into a calculator. I know it's going to be a little more than 5. Because think about the perfect squares that are around the square root of 26. So the square root of 25 is a perfect square, and that equals 5. 26 is super, super close to 25. So that means this is going to be like 5.1-ish. I'm going to put into a calculator right now. And it's also next to the perfect square of 36, which is 6. So it's going to be a decimal between 5 and 6, much closer to 5. So let me put that into a calculator real quick. It's 5.09, but if we round, it's 5.1. So the distance is 5.1. Of these 2 points, the distance between those 2 points is 5.1. I'm going to give you guys one more example. But instead of drawing a diagram, I'm just going to write it out. So we're going to find the distance between negative 8, 13, and 12, 1. And I'm not going to draw it out. I can, but I'm going to try to teach you the distance formula just numerically. So the distance formula, try to memorize it. It's d equals the difference in the x's squared plus the differences in the y's squared. And I'm going to extend. It always happens where my square root isn't long enough. There we go. So now I'm going to call my points. I have my first x, my first y, my second x, and my second y. And remember, we say that x sub 1, y sub 1, x sub 2, y sub 2. So now we're going to plug in our values. So we have 12 minus negative 8. So we have 12 minus negative 8 squared plus we have 1 minus 13 squared. 1 minus 13 squared. So 12 minus negative 8 is the same as 12 plus positive 8, which is 20. So we have d equals the square root of 20 squared plus 1 minus 13 is negative 12 squared. Okay, let's rewrite that. So we have d equals the square root of 400 because 20 times 20 is 400 plus negative 12 times negative 12 is 144. And then we add those two together and we get 544. And that is not a perfect square. And I honestly don't know what the perfect squares are around 544. That's a really big number. I think, don't write this, okay? I'm just trying to be a little bit of a math nerd. I think the closest square root to perfect square root of 544 is 625, and the square root of 625 is 25. That's my guess. This is my guess. But let me put 544 into a calculator. So my estimate is that it's going to be 24 point something, if I had to guess. And I might be way off. Let's see. Oh, I was close. So it wasn't that, that's not the closest one. The closest one would be 24. And 24 times 24 is 576, the square root of 576. So that means 23 times 23 is the other closest one to it, which is 529. And that's a perfect square of 23. If you don't get this, you should review square roots. It's called approximating square roots. Anyways, back to our original problem. So the square root of 544 is 23.3 if we round. So my original guess was 24 point something. I wasn't too far off, but it's actually 23.3. That's the distance between those 2 points. All right, guys, I do want you to show your work. Use a scratch paper for your edge elastic. Don't just guess and check your answer. You really want to understand how to find the distance between 2 points. Thank you. Good luck.